All right, I am Dave Zolotusky. I am a backend engineer on Spotify's infrastructure team in Stockholm.
I'm James Wen, also an infrastructure engineer on the New York side of things. Right now, I primarily work on the Kubernetes migration for Spotify.
Cool. And we're here to tell you guys about Spotify's infrastructure transition of the past few years. Oh, maybe. All right, so a few years ago, we were running all of our infrastructure, all of our services, all of our data jobs, everything in our own data centers around Europe and the US. About a couple of years ago, we started looking into moving out of those data centers and moving to being cloud hosted. And then we're going to talk about the last step, which is really where we are now, where we are almost entirely cloud hosted and really figuring out what the next steps are, how to be more cloud native, how to take services that really weren't born in the cloud at all and make them operate and feel like they were. So let's start at the beginning. Let's start with what we had in our data centers and what our services looked like when we were running in data centers. We had a whole bunch of custom things, but we also picked up a fair amount of interesting new technology. We were a fairly early adopter of Docker containers, and we were running a lot of our services, our Java services in Docker containers in like 2013, 2014. We built our own container orchestration engine because at that point there really weren't great engines available elsewhere. And we eventually actually open sourced this thing. This link goes to our GitHub page. We open sourced it right around the time Kubernetes was open sourced or announced. But obviously Kubernetes didn't exist at the time, so we couldn't use it. We have our own custom monitoring platform. We have a time series database we call Heroic, which is open source. It's based on an open source time series database called OpenTSDB, but has some differences that we needed. And then we have an internal, we have an open source dashboarding system we call Alien that does our dashboarding, our alerts, and gets us paged. And the internals of all of this stuff is based on things like Cassandra. We use Elasticsearch for metadata, and it's all kind of globally federated through our data centers so you can get single dashboards for all of your services. On top of that, we have our own proprietary message protocol, this thing we call Hermes. It's based on 0MQ. It's mostly protobuf over 0MQ, and the biggest drivers for having our own protocol were that we needed message multiplexing over single TCP connections. And back when we were starting to do this, around like 2006, 2007, there really wasn't anything available like that. There was no gRPC, there really wasn't an HTTP2, and most of our services, most of the streaming things we needed to do, we really couldn't do over things like HTTP1. We have our own custom Java framework, this thing we call Apollo, which is open source but has modules, some of which are open source, some of which are not. And you can think of this thing as something kind of like Spring or Spring Boot, but obviously our own internal thing and not nearly as kind of full-featured. And it has built-in clients for things like Hermes protocol and for heroic metrics and all of our other kind of custom pieces. It's really a way to kind of bootstrap a service, give all the kind of initial boilerplate code that all of our services need. Most of our storage was either in Postgres and MySQL for kind of very early Spotify. It was almost entirely Postgres. Then, as we grew enough, we started switching over to Cassandra, and then really more recently, Cassandra has been our kind of one database for everything if we can. And that means that we have an incredible number of Cassandra clusters that cover almost every use case. We have huge ones. We have like 3-node ones with a few megabytes of data. We have ones that get incredible amounts of read load or write load, ones that get a request a day, kind of any possible use case, we probably have a Cassandra database somewhere in our deployment that has that rough use. And of course, that means that we have a lot of experience throughout the entire company on kind of operating these Cassandra clusters, and we have a team in our infrastructure team that is kind of really Cassandra specialists for all of these different use cases. The other really big thing we used a lot of is Hadoop. We use so much Hadoop, in fact, that we had the largest single-tenant Hadoop cluster in Europe. This thing ran, I think it was just over 20,000 jobs a day when we were kind of at its peak. It had around 3,000 nodes. It ran kind of hundreds of different types of events. It got hundreds of thousands of events per second in some specific streams. And many, many more than that when you combine all the streams across all the clients. And many of the data pipelines that it ran of those 20,000 jobs were kind of complex chained pipelines. So it would be some long Hadoop job that then fed into 3 or 4 different jobs, and each one of those might have fed into 3 or 4 different jobs, and so on. So we had to, like, just drawing out the full kind of set of all of our pipelines from start to finish itself would take kind of more than most of this board, probably. And we ended up having to build some of our own tools, some of which we open sourced, like this thing called Luigi that does the orchestration and ordering of all of these jobs, just because there were so many and they depended on each other in so many different ways. And then kind of tying all of this together in a similar way to the way that Apollo was our framework for allowing services to kind of bootstrap and get going with all of the backend things tied together. We have this concept of a golden path, which is something like Netflix's paved road, if that's what you've heard of more. It's kind of a documented way to tell a developer within our team, if you want to create a service, follow these steps, and you'll have a blessed kind of official Spotify way of creating a service. And we started having a few of these. We had one for kind of how you create a data pipeline, how you create a backend service, and so on, how you create a mobile feature, et cetera. And a lot of these things come out of our tech platform org. So we have close to 4,000 employees, and we have a 500-person or so tech platform org, of which 200 to 300 is just infrastructure and operations and data infrastructure. So people that run all of these things and just ensure that all of our backend services are using kind of reasonable new technology. We're doing things like moving over to cloud, what I'm talking about now, and then like the data infrastructure team is things like maintaining all of the tools that we had for the Hadoop cluster and transitioning all of that to cloud. So we had all of these things in our data centers. We had all these proprietary tools, and eventually we realized that kind of it's way too much work to maintain all of this stuff. There's so many things that just are not our core business. We are, at the end of the day, a music streaming service, and even though we're a fairly large company, we're not big enough to kind of have enough people to really focus on running data centers and running all of these things. So mostly for the sake of focus, but also for all the other benefits everyone talks about, the elasticity, the managed services, all of these other great features. We knew we wanted to move to cloud, but at that point we really had no idea kind of where to start, how to do it, what to do. We just knew that we wanted to do it. So we decided that the right thing to do would be to figure out kind of stages, to figure out milestones, to do it like any other software project. And our first really big goal was just move out of our data centers, like set the goal as stop paying rent, kind of stop having data centers, and then we'll figure out the rest later. And that's exactly what we did. So our platform teams, infrastructure and operations teams, data infrastructure, all these teams then kind of got to work on figuring out what that even meant for everyone else, because everyone else in the company is building features, is building their services. They don't want to have to think about kind of what is running their services. Ideally, that's our problem. So we went through and figured out kind of the network connectivity between our data centers and our cloud providers' data centers. We figured out how to kind of extract away machine provisioning so that the tools that all of our developers used to use to provision machines now could provision VMs in a cloud data center. Things like deployment, same thing, kind of they could just say, I'm deploying this service and it ends up in the cloud instead of in one of our data centers, but it feels the same to them, so we're not teaching them all new things. Service discovery, of course, also had to work cross-cloud. All of these things kind of came out of the platform before we did anything. After that, we really had to go on kind of a tour across the company to get every service moved and get all of that working. So the platform team at that point kind of went around the company working with services. The next big thing, that giant Hadoop cluster. And this really was the kind of the harder part, because with services, it was a lot easier to just say, you have bare metal infrastructure here, you have a VM there, kind of looks and feels the same, it's still Linux, it's still running a container, it's still using the same container orchestration system, we can fake it. With data jobs, it was a lot harder because we really didn't want to just spin up 3,000 VMs that looked like our Hadoop cluster and create the world's largest single-tenant Hadoop cluster in someone else's data center. But because we have these really complicated data pipelines, the initial thought is kind of we have to start either at the beginning of all of these pipelines or at the very end and then move the other way. And that was really hard too, because the jobs at the beginning or the jobs at the end may be owned by one of many different teams. They look and feel very differently. It would have been very difficult to kind of coordinate everyone on either end of this kind of complicated data pipeline to really start and flow across. And then like one team has to move their first job, and then they might own the fourth job, so we come back to them 2 weeks later. It just wasn't going to work. So we kind of came back within the data team, thought about what else we need, and created a bunch of tools to make this easier. Obviously, we needed better network connections between the data centers. We needed to figure out kind of how we were going to run jobs. We figured out all of the kind of core pieces. And then one of the people on our team had this idea to make it so that we could just move any given job in the middle. And the way that we were going to do that was we created this tool called Spidero, and we did open source it. And it effectively lets you create kind of ephemeral Hadoop clusters in any cloud provider that lets you have Hadoop clusters and then tear them down. But on top of that, it lets you pick with a command line flag if you want to schedule to the on-prem one or in the cloud. So at that point, we did have to have the feature teams change some things, but all they really had to change was add a flag that said, like, we've tested this and we think it works in cloud, so now, like, Spider kickoff job -- cloud, as opposed to just leaving it by default. The other thing we needed, of course, now, if we had random jobs in this giant pipeline going in one place and random jobs in the other, was a way to have them reach their data. So we kind of created a modified version of Hadoop distributed copy that just copied from our HDFS into blob storage in the cloud and back. So by combining these two tools, we really let any pipeline anywhere in the middle now move, and then if the pipeline consuming it was in the other place, then it would just run dist copy at the beginning to copy the data over to itself, and the same thing afterwards. If your job moved and the job after you didn't, then you would just have to copy the data back so the job after you can run normally, and then when that job moves, you no longer do the dist copy, you just run next to it. And this was really the biggest thing to let us start moving our data jobs. At this point, we now could just go to individual teams and say, hey, we want to work with you, let's move all of your jobs. And it didn't matter where they were. Let's work with you guys, we'll move all of your jobs. The biggest problem with this, of course, is we're constantly running distributed copies. We maxed out the pipe we had between our data center and our cloud providers constantly and kept growing it all the time through this. But once it was actually done, it was amazing, and we had moved 20,000 jobs a day in this enormous Hadoop cluster, so despite all the pain, it was absolutely worth it. So now we're effectively moved out. There's always a long tail of things, but the intense majority of the things we've done have moved out. This was overall probably about a 3.5-year effort from deciding we need to do it to being where we are now. But the biggest push was 2017. At the beginning of the year, we really had a lot of the infrastructure for moving, some of the network connections, the ideas for how we were going to do it, some of these open source tools, and the internal tool I just talked about, but very little was actually moved. And over the course of 2017, we basically had both the infrastructure team and the data team in our platform move across the company and get everyone over. And through this, we built a lot of amazing relationships, both with varying communities that we worked with on some of these tools, and of course, our cloud provider and some of the other providers and people we talked to just to give us ideas on how to do this. So we're done, right? Of course, at this point, we're not. We're now running a replica of our on-prem data centers in someone else's data centers. So sure, we don't support the hardware, but every one of those proprietary things I just told you about, we still have. And we're not getting great utilization of hardware, we're not getting great use of all the managed services, and we're just still not completely focusing on streaming music. We still have a whole lot of stuff to do. So now we need to figure out what it means to be cloud native, to feel like we're born in the cloud. But we didn't really even know what that meant. We'd been running in data centers forever. Like, sure, there's auto-scaling, and there's open source communities, there's managed services, but what do we do? So we figured we'd start somewhere relatively obvious and just start experimenting with things like Kubernetes and gRPC and figuring out how to do the simple, the right sizing, the auto-scaling, all of this stuff. I'll let James tell you about the Kubernetes side of that.
Okay, so I'm going to talk more very explicitly about how we're migrating to Kubernetes, like what we've been doing, what we're doing, and what we're going to do. So our goal here is to run all of our stateless backend services on Kubernetes. And the approach we took was very iterative one with procedural stages, and each stage is a very succinct goal. So for our very first stage, it was kind of an experimental one, and we sought to just run one service on a single cluster and have that service receive production traffic for just 1 hour. And so despite that being a very small goal, it drove out a lot of things for us. For example, we actually needed to create cluster. At this point, it's manual process since it's a single cluster. We needed to set up DNS, networking, routability. For example, we needed to set up the correct upstream name resolvers, IP mask queue agents, so that the infrastructure stuff for clusters and the service could resolve the correct host names for our internal Spotify stuff. We needed to set up integration with our existing service discovery, which is an in-house system called Nameless, so that other backend hosts and services would know to talk to this service running on Kubernetes. We needed to set up integration with our existing metric system and logging, so that we knew that the service was operating correctly, it was receiving traffic, and was responding to requests properly. So that all worked as expected. And then for our next experimental phase, we sought to run 3 services on a shared cluster. So now we introduced the element of multi-tenancy, albeit on like a very small scale. And so with multi-tenancy, now we need to think about namespaces and permissioning and resource quotas for those namespaces to prevent those 3 different teams with their 3 different services from stepping on each other's toes, both from an RBAC and permissions perspective, but also from a resource utilization perspective. And we also start to create more fleshed out developer documentation because up to this point, we were dealing with a single team. It was easy enough to jump in their Slack channel or schedule a Google Hangout meeting and talk to them directly. But now we don't want to have to repeat the same exact message to 3 different teams and later multiple teams. So now we start to write developer documentation. So after that, we've ended the experimental phases because at this point we've gained enough confidence to say that we can probably run most of our services eventually on Kubernetes. It's just figuring out kind of the how of things and all the unknowns there. And so now we enter into the alpha. Sorry. Now we enter into the alpha phase. And so in the alpha phase, we took volunteer services and partially ran them on Kubernetes. And we did this. Via sending out a survey via an email to all of R&D that asked interested teams to volunteer their services to run on Kubernetes. And there were 2 intentions here. The first intention was to elicit volunteers, but the second was also to let all of R&D and our internal stakeholders know of our intentions for Kubernetes and where our runtime platform was headed. And so most of the services volunteered for this were Golden Path services, and they have a variety of like minor tweaks or quirks like co-located memcaches, requiring GCP service credentials to operate, minor things like that. But for the most part, they're Golden Path services. So we're pretty familiar with them and we know how to deal with them. And so for this phase, it drove out the need for test clusters because previously we were running services for say an hour or a few days, but now we're running them indefinitely. So we want to isolate the clusters that we experiment with resource manifests on away from the production clusters. So we now have test clusters. And with the test clusters, we now have multiple clusters that we want to have mostly the same configuration on. So we script out the creation of those clusters. We start to automate that process. And then we integrate with the existing secret system. So we have an in-house system called Silo, and a lot of services rely on this system. So we basically write integration that automatically puts their Silo secrets as secret resources in their namespaces, so they don't have to worry about that kind of stuff. Note that for this, it's kind of a stopgap solution. In the future, we want to move to something more like Vault, something more robust. But for this phase of our migration, it's not really necessary. We're only dealing with a small amount of services. And the next thing was initial deployment. So for this, we wrote a pretty small wrapper around kubectl that developers could install on their Jenkins instances and manually invoke in their pipelines, just like a 1 or 2 line thing that would deploy to the clusters, the production clusters that we have set up for them. And right now, this is like good enough of a solution because we're dealing with, say, less than 20 teams, less than 20 Jenkins instances. And in this phase, we got a lot of learnings from running these this variety of services. I'm not going to go into full technical details, but for example, we found weird MTU networking issues. We found some unexpected behavior with readiness probes. We found syscontrol RMM max issues with the packet buffer size on nodes. That kind of bit us. I see some people nodding actually, so it looks like we're not alone there. We also ran into the limitation with kubedns, where it didn't support reverse DNS lookups for upstream name resolvers. But props to the kubedns team, because just 2 weeks after we created that issue, they added that feature and then closed out the issue. So we were really impressed with the really quick turnaround there. An important part of this kind of alpha phase was that we really wanted to run 2 high traffic services on Kubernetes and have them work successfully. The 2 we chose were fanout and metadata proxy. Fanout you can think of as an internal pub subsystem. Metadata proxy you can think of as the gateway to all of the metadata at Spotify, so all that mission critical song and artist info. In terms of load, fanout gets about 1.5 million requests per second, and that works out to about 15K requests per second per instance. And for metadata proxy, it receives about 500K requests per second and 500 requests per second per instance. So fairly high traffic services. And so what this drove out for us was we started to use and experiment with autoscaling, horizontal autoscaling at this point. It really forced us to understand the nitty-gritty of our network setup because of the low latency requirement of these services. And most importantly, it served as a great reference for other teams who were migrating. We had direct feedback from some teams during migration that they were initially worried about their services, how they were going to run on Kubernetes. They thought they had complex services. But we would point them to the example of these 2 services that were able to run on the Kubernetes clusters that we set up. And that, for the most part, alleviated their fears because their services were, for the most part, less complex and had lower performance requirements than these services. Thank you. So the next phase after the alpha phase that we recently wrapped up is the beta phase, what we consider the beta phase. And in this, we have self-service migration. And so in here, teams that are interested can follow infrastructure-provided docs, guidelines, tooling to self-service migrate, either partially or fully, their capacity from the old Helios runtime to this new Kubernetes runtime that we're providing. And so the 2 elements that we introduce here are that as operators, now we have stuff running in our clusters that we're not familiar with. So for the previous stages, when we worked with teams, we would do most of the legwork involved in getting working resource manifests, creating PRs, and really hand-holding them along the way. But now teams could theoretically migrate their services to Kubernetes without ever actually directly conversing with us as the infrastructure team, which is actually the intention there. And the other part is that we would support full migration. So whereas before with partial migration, they're both running on Helios and Kubernetes. In the case of an incident, it's what we recommend for them is to just destroy their Kubernetes capacity and fall back on their already long-standing Helios capacity that they know how to deal with, that they have a lot of experience with. But with full migration, this no longer becomes as easy, and we need to introduce a lot of reliability on the part of our clusters. So we start to look at reliability, we start to set up on-call for our clusters and the associated alerts and playbooks. We do dirt testing for disaster recovery and backups. On the service side, we start to think about how do we let developers create their own namespaces, but have those namespaces set up with the proper RBAC permissions and sane resource quotas so that they don't have to really worry about these kinds of things. On the deployment side, we start to look past manual command invocations in Jenkins pipelines and look at a more robust deployment orchestration layer. We chose Spinnaker for this. And side note that we're kind of on the bleeding edge of Spinnaker in that we're using the new V2 Kubernetes provider. So if you're using this and you have any thoughts or want to compare notes, we're highly interested in that. We needed to make a decision on how to store manifests in terms of version control. What we decided on for the time being is to store all infrastructure-related stuff in a monorepo and have developers' resource manifests co-located with their application repos. But we designed everything in a way that we're not fixed to this and that we can migrate to other paradigms if needed later on. And so the phase after that is the golden path phase. So this would be GA, general availability, and this would be where any new service at Spotify would be deployed to only Kubernetes and have be able to leverage all the native Kubernetes benefits like autoscaling via the vertical pod autoscaler. So that would take away some of the capacity planning concerns from developers. Horizontal node autoscaling would take away some of our operator capacity planning concerns. The one-click migration is kind of the golden goose here in that we would like to provide either a button in our UI console for everything called systemz, or a simple script or a CLI tool that would be able to convert developers running services on Helios to Kubernetes for them, so they don't have to follow some long series of docs or guidelines, ideally. Everything else falls into this category. So following the 80-20 paradigm, this would entail us investigating the 20% of kind of tail end services that have additional requirements. For example, ITGC services, like IT General Control Services at Spotify, have additional security and auditing requirements. For example, all SSH activity currently needs to be tracked, monitored, and audited. So in Kubernetes, we need to figure out what does this mean? Do we track kubectl exec? Do we just not allow them to do that? These are things that would need to go into GA. We would also do migration tracking as part of this phase. So we would actively track via metrics how many services are still running on Helios, how many are migrated to Kubernetes, the rate of change from one to the other, and hope to boost that through things like the migration road team. So this is a strategy we used during our GCP migration with a lot of success. And this was a temporary team that was spun up that visited all the offices that had developers in them. And this temporary team held lunch and learns, like GCP trainings, and sat down with developers to actually help them migrate their services to GCP. And then when we were all migrated to GCP, this team spun down. So we hope to do something similar for Kubernetes. And so the takeaways and lessons we had from the migration process we've done so far is that scoping this into stages really helped us avoid a very monolithic migration movement. When we were initially thinking about things at the very beginning of migration, especially with our long-standing legacy stack, we were really thinking, oh my God, there's so much stuff that we need to integrate and adjust to fix. There's just so much stuff, especially because we've been around. This legacy infrastructure has been around since 2005, 2006, and whatnot. It's a lot to deal with. But designing each stage around the type of service, the scope of the service that you want to migrate, really helped us in terms of discovering all these hidden unknowns that we knew were out there at a very controllable pace. And so when we discover these unknowns, what we would do is basically consider, does this need to be part of this migration phase? For example, secrets integration at the experimental stage when we were running 3 services. Do we need to solve that? No, we don't. Let's put it on a backlog and remember to address that in a later stage, the one that's relevant. And so the caveat to that is to, when in doubt, leverage time-boxed investigations to reduce risk. What we mean by that is that when we were throwing these things on the backlog, very often some team members would have fears that when we later need to implement this thing, we're going to have to rewrite a lot of the existing stuff that we just did for this current stage, and that we kind of did in maybe a hacky or quick way. So to alleviate those fears, we would have a team member basically take a time-box investigation into alleviating that fear. So for example, in our Spinnaker integration work, for the beta phase, we were seeking to do a simple deployment pipeline. In GA phase, we're looking to support canaries, blue-green deployments, more complex stuff. And so we were worried that the integrations we were doing with Spinnaker for beta, we would have to rewrite for the GA phase. So a team member took a day, really dug into Spinnaker pipeline design. They manually created a canary and blue-green deployment pipeline, and they vetted that, okay, what we're currently doing with Spinnaker will allow us to easily support complex strategies later. So we greatly mitigated that risk there. And so that's our Kubernetes migration so far. That's the runtime side. Dave is going to talk about the protocol side of things.
Yep. So there's still a few more of those things I talked about earlier that are custom things that we'd like to get rid of. At the moment, the top of the list is Hermes. That's our protocol. Having a proprietary protocol is really not a lot of fun. None of the great L7 features we can get from cloud features like cloud load balancers work. We can use a service mesh, but we don't get any of the cool L7, any of the protocol inspection features of that. We obviously don't get any free features from someone else doing work on the project. It's harder to onboard new people. It's harder to onboard new languages. It's harder to get kind of debugging deep into the protocol. If you see some messages and you have to figure out what's going on, you have to kind of dig through the code as well, just because there really aren't great tools aside from the ones we built when we had some issues, so we needed something. So we really want to switch protocols. But on the other hand, it's really hard when you have, say, 1,000 production microservices that are all communicating in some protocol to just flip a switch and make them all speak a different protocol. So similar to the Kubernetes migration, we're trying to figure out how to stage this. And some teams have just said, we're going to use gRPC because it's just better, and even if the infrastructure team isn't providing it, we don't care, we want gRPC. We're working with those teams to kind of understand how they did it, to understand what they're doing, to understand how they're interacting with the existing Hermes services, and to create a model for the rest of the company so that we can move across there. Obviously, if a whole bunch of our existing services are still speaking Hermes, any new service will still need a Hermes client, but ideally we don't need Hermes servers anymore because they'll all just serve in gRPC and connect to the older services or the not yet migrated services over Hermes. But that still leaves a whole bunch of big questions for us. Things like, kind of, do we migrate all the old services? Do we migrate some of the old services? Do we kind of not migrate anything, just give tools to create new ones and see if the feature teams care about their old ones? So far, we're kind of leaning towards a middle path of trying to migrate the most critical services, but kind of give help in supporting the others, but not necessarily be personally involved, because there are over 200 teams we have and only so many of us in infrastructure. But I'm happy to hear anyone else's stories of similar migrations to see what they've done and what's worked. The other really big thing we're trying to figure out with migrating gRPC is schema management, like protobuf schema management. With our existing protocol, we've found that some of our more critical services have over 100 different clients spread across all of our internal code bases. We don't really want to have over 100 different versions of the same protobuf spread across all of these repos. So we're trying to figure out how to do that because we don't have a mono repo, but we also don't really want people copy and pasting each other's proto files into their repos. Right now, we're leaning towards building a schema management tool and open sourcing it and kind of seeing if the rest of the community picks it up. We're happy to, again, kind of hear what other people in a similar situation do here and potentially work with them to build something good. And the other thing everybody's talking about at this conference is istio. We kind of clearly want to use istio. We see a lot of benefits from things that it does. We have done a few POCs, but they've been very simple. We did a quick POC just to see, like, will it work at all? If we deploy a bunch of istio sidecars with our services, does everything break? And that obviously didn't happen. It worked fine. So we filed a few bugs with istio, a few bugs with Envoy, but overall it worked. Then we moved on to testing service-to-service authentication. And we still have thousands of VMs. We will probably for a very long time. We'll have services in multiple different clusters. So we were figuring out service-to-service auth with services across clusters and across VMs and found that we can make it work, but there are a lot of pain points. So we're kind of still figuring out how to smooth those over or try to get it so that by istio 1 or by the time that we have time to really deploy istio, we can get them fixed. And the next thing we really want to investigate with istio is tracing, kind of how to do good distributed tracing with it. And then we're trying to figure out kind of what our next thing. We're working with the end user community. We're looking at other projects, whether it's Prometheus or some other things that we haven't listed here. We're looking at non-CNCF things. And then there are other big things like we have no plan right now for how to replace our framework for Apollo, but we don't really want to have our own framework once we're kind of Kubernetes and gRPC and istio and running with all these kind of community tools. So we're still figuring that out, and again, kind of we'd love to work with people in similar places rather than invent this on our own. And that's it. We're happy to take a few questions if we still have time.